So let's go and discuss this. So what will happen if you take these columns? So it will applicable only the numerical columns. Okay, it may not be applicable to the categorical, but we have only the numerical columns in our data set at last. So let's go this train data set. So we are applying to the train and also the test. What the rescaling of the data. You can see it is converted to the whatever the raw values we have, it converted to the 0, 1 in the range of the 0, 1, even in the age also. Yeah, let's also try to implement the logistic regression. Just now I told you, right, it will get it from the scikit-learn itself. In the linear model you will get directly import the logistic regression. You can also call maybe the alias for that matter as a log regression. So the KPI matrices we are currently using as F1 score. Let's assume this is some score you want to evaluate by using the logistic regression. I will also explain this with you maybe after a couple of the classes. F1 score, something called as accuracy, and log loss is something called as a blue score. We are going to be using the Indian filtered context. Yeah, so just calling our logistic function by using some variable logistic and fitting our model. This is how we are going to be fitting our model w yi into w transpose into the xi. So we are just taking consideration for the train examples and also the labels of the train samples what we had. So if you fit this function, you will get all these parameters. Okay, so you can also directly showcase here itself in the whenever you initialization of the logistic regression. But what will happen if you eventually may not be go, we can call it as a baseline model for this one. And if you directly use these parameters by using any hyperparameter tuning techniques like grid search or random search, that will calculate the whatever the fitting of this corresponding data set. So if you don't know any parameters, what you need to do, go to the documentation. So eventually every industry is going to do the same thing. Okay, this is not a new time to do this. So scikit-learn logistic regression, you can mention as a doc, it will guarantee give this link. According to that, you go and learn what exactly the parameter does. What is the penalty? Penalty is nothing but a regulation term. What is the L2? L2 we already learned, right? It's corresponding the value to reduce some of the minus infinity to positive points. And dual function. C is nothing but which is the inverse function of the lambda. Okay, so C is nothing but C is equal to 1 by lambda. C is equal to 1 by lambda. So you know, right, lambda, then the lambda is equal to 1 by C. So whatever the hyperparameter tuning you are doing with the corresponding to the lambda, you can directly take by lambda. That's it. That is the basic approach you have to follow with any kind of the logistic regression. And fit intercept, if you don't know any concept related to this, just go to and check this documentation. Penalty, dual, total, and the C weighted vector and the fit intercept, something called other things, class weight. So whenever you have imbalanced data set, you use class weight is equal to balance. Random state, if you want to initialize randomly or not. So these are all the parameters. No one is going to remember these parameters, obviously, because we had tons of the parameters in the scikit-learn documentation. Whenever we need, we are going to be checked by the standard parameters like hyperparameter tuning and somehow like class weight is going to balance whenever you get the imbalanced data set. At the time, you're going to be check the documentations. Okay, so let's fine tune this. We are just fitting our model into the X train and also the Y train. What will happen if you just predict this model? So you can see if you predict this model, it consists of the zeros and one. That means whether the person is survived or not, it's going to be showcasing. But how does internally will happen? Let's go and check the probability values. So you'll also get the score, something score. You just ignore the F1 score as of now. Something score you got around 0.74. That is the 74% you got. It's corresponding to the train data set. And what about the test data set? Corresponding to the test data set, you got around 75%. This is slightly fitting of this model very brilliantly when compared to that. But 74 may not be satisfied with the end user, I can say. He needs somehow around 0.5 or above the 0.5. Yeah, so internally what will happen, it will predict some of the probabilities like this. It will be scaled between the 0, 1 as we just now discussed with corresponding this block, right? it will varies only the 0, 1. Yeah, you can see here, it will varies only the 0, 1. Whenever you see some unseen data point or outlier of the detection, it will convert into the 0.5 result. Somehow the probability value going to be showcased. We can also showcase as a coefficient of this matrix. Yeah, so yeah, you can ignore this KPI matrix as of now. We'll go and discuss that maybe later. I'm just explaining how does logistic regression is going to be helpful. For the coefficient, you can see this is varies like this. Whenever you have some of the coefficient with corresponding to the, you can say the logistic regression, it varies between the 0, 1 and also the negative results as we seen in this diagram. Some of the negative results going to be showcasing and the positive results going to be showcasing after completion of the 0.5 result. And you can also train by using future importance to get some of the future importance. I think we have done this. Yeah. So if you want to showcase more than you can say coefficient is greater than 0.3 results by using this plot, you can take that consideration and just give a plot like that. So I'm just taking the coefficient more than 0.3 results. I'm again plotting the same thing and again testing by using the logistic regression. And somehow we are going to be get the results like this. When compared to that plot, it is slightly very good, and the negative results are we are reducing when compared to that above the plot. So let's jump on to a project and try to implement this, and we will also get the future importance according to that. Okay, so we have standard libraries like pre-processing steps by using the label encoder, standard scalar. So these are some rescaling of the data. This is some feature engineering hack and logistic regression, and something called as a k-fold cross validation technique and train test split. We are getting from all the from scikit-learn. Okay, so these are the KPI matrices. You can ignore as of now. We'll go and explain in detail maybe tomorrow or day after tomorrow. Yeah, so see, we're just importing our CSV file has a data. So these are some of the raw data we have with corresponding missing values. So these are the major hacks to try to handle with corresponding to this data set. Something called as a gender having 512, 525, and also the dependent is and 2400, and the city also having 80 like this. So we need to impute or we need to identify or fix this issue. How to impute these missing values in this data set, and what are the different techniques we have. So if you take this gender, it is an ordinal column, obviously, whether it is a male or female. Then let's check how does that going to be helpful with regarding the male and female frequencies. The male frequency is around 60,000 and the female frequency is around 11,000. So according to this value, what we are going to do? So you have around, I can say, 525 values as a missing values. So how do you impute by using these frequencies? So one technique is you cannot be identify the missing values whether the person is a male or female. But by using the mode method, we cannot be identify whether he is a missing value is a male. So in this case, we can directly cause one solution here is whenever we don't know that much of integrity to understand like ordinal columns, you can directly impute something called as a -1 result. That -1 result going to be help us. We don't know the person having male or female identity. So at that reason, we just converted into the numerical value instead of taking only for the mode results or frequency of the male result. So most of the people will take as a mode results. Obviously, I can say that. But what will happen if you take the male results? It will model may not be works out well. The feature importance is completely biased towards your male only, not with regarding the female, because we are calculating the distance between right the futures in the logistic regression model. So somehow we are going to be convert this male and female to the zeros and one, and we don't know about some other values like a missing values. We just replace it with a -1. So that's what we are doing, just replacing with -1. We use fill now. Fill now is a predefined function. We already discussed that in the Python videos. And yeah, just converting our ordinal codes with 1, 0s. If you just do that, it will directly convert and missing values to impute with -1. And similarly, dependence. So dependencies we have with corresponding the missing values. I think we have so many missing values in the dependencies. So let's go and discuss that what are the different frequency terms we had. So you can see the most of the dependencies having very less frequency and only the few having very high frequency. This is a missing value. Obviously you can see the 2 and the 1 having the more you can say more frequent kind of the thing. So in this situation, what exactly we had to do, we just fill with some of the values with zeros. So some of the values with zeros, because we don't know that much of integrity to identify, because this is also some numerical column. So we need to identify with that. Why not we go with a -1? So if you just apply with large set of the values, so you can see here, you have total around 20,000, right? So if you apply large set of the values with -1, it will completely bias towards our negative results. That means it can completely bias towards our churn prediction to automated to bias towards only the negative result, because logistic regression works with the positive and negative results at the end. It may not be calculated the majority would, other than the other models we had. And if you take somehow with regarding the zero, it may not be do any kind of the operation without some of the missing values. It will be only identify with somehow whatever the frequency of the other values we had. Because it having more number of the values, we have to reduce or we have to drop it maybe. But according to our data leakage problem, we cannot be do any kind of the dropping mechanisms. Anyhow, we can reduce by using the 0, 1 by using the standard scalar or the normalization, right? And occupation results also having very missing values, but these are the some frequencies. Self-employed having more you can say more frequent numbers when compared to the all. I think it had around 8 and sorry around 80 only, right? So that's the reason we are just imputing.